Hello students, today we have to perform an experiment on gyroscope. Basically a gyroscope is a heavy rotating wheel which has got 3 degrees of rotational freedom, right? Here is basically a setup, a model you can say of a gyroscope. In this setup we see there are two major parts. One part is the gyroscope, the another part is the controller, right? And in the gyroscope the most important part is this rotating disc, right? Actually this is the vital part of the gyroscope. And as I told you, it has got 3 degrees of rotational freedom. That means the setup is manufactured in such a way that we can give 3 types of rotational motion. Number 1 is this. Here what happens? This disc is rotating about the central axis, right? Second is the bracket on which the disc is fitted can be rotated in another axis. This axis is perpendicular to the previous axis, right? And now third is we can rotate the whole setup about a vertical axis. See, so ultimately we find that there are 3 mutually perpendicular axes about which the setup can be oriented. First is this axis, and this axis about which the disc is rotating is called the axis of spin, right? And the axis about which the whole system is rotating, that is called the axis of precision, right? And the third axis, the axis of gyroscopic couple. So all the 3 axes, they are having different names, and their names are also very important when we have to verify the law of gyroscope, right? Now let us see the detailed parts of the setup. If you see, because ultimately we have to rotate this disc. For the rotation of the disc, there is a motor fitted over here to provide a sufficient high rotational motion. Students, now I would like to explain the major parts of this setup. See, first of all, there is a base. On this base, this frame is fitted, which can be rotated about the vertical axis, right? Y-shaped frame is there, and on this frame another bracket is fitted where this wheel is mounted on 2 bearings, right? Bearing 1 and bearing 2, just to minimize the friction, right? And to provide a rotational motion to the wheel, we have got a motor over here, and with this motor we can increase the speed to a very high range. You can say about 4000 rpm, right? Because if you are putting a motor over here, what happens? It creates imbalance. Just to balance that, a counterweight is fitted over here. So the function of this mass is nothing but to counter the torque produced by this motor. So it is just a balancing weight. The whole assembly of the wheel, spinning wheel, has been supported by 2 bearings, right? These are known as plumber blocks. Okay, and now one thing is to observe that there is a scale over here on the base of the gyroscope, right? Now when we start rotating the flywheel with the help of the controller, only the flywheel will be moving, right? And everything will be stationary. Now we can observe it just by switching on the motor of the gyroscope, right? To switch on the motor, first of all we will supply power from here. Students, now we will switch on the motor using the controller. The controller is provided with an on-off switch, a display unit, digital display, and a regulator. So we can regulate the speed with the help of this regulator, right? One thing has to be kept in our mind: while we are starting the motor, the regulator should be placed at its minimum value. Otherwise, suddenly the speed will be very dangerous to operate. So we will keep it at the very minimum level, and gradually we will increase the speed up to the desired value. And now let us see this, how we are controlling the speed. First of all, we will switch on the power over here, which goes to the controller, and from the controller the power is being transmitted to the motor fitted on the gyroscope. Let us first of all put the knob of the regulator at the minimum position, and now let us switch on the regulator for power supply. Now the indicator indicates RPM, which is 0 right now. Now we will gradually increase the RPM. Now we can see the behavior. The speed of the spinning wheel gradually picks up. Now we have to wait so that the speed is maintained at some constant RPM. In the meantime, we observe that after switching on, the speed of the spinning wheel increases gradually, but there is no effect other than rotation of the spinning wheel. Now the interesting observation, we will find that if we put some weight over here, the behavior will be changed. Perhaps if we don't know the law of gyroscope, we will not be able to predict what is going to happen. Let the speed balance stabilize to certain value, maybe 1000 RPM, and then we will try to put some weight on this. Wait for 2-3 seconds and please monitor that the speed is gradually picking up. At a lower speed, the performance will not be as expected. There is a reason behind it, but right now let us wait for approximately 1000 RPM or maybe a little bit more, just to observe the effect. Now the RPM is almost just crossing 1000, and at this point now we can observe the gyroscopic effect, let me put a weight over here, but this weight has to be put very smoothly so the system is not disturbed. Now see what will happen if I leave this. You may be expecting that this will be coming down, but no, it will not come down. It will have a rotational effect, and that effect will be known as precision or precessional motion. Right? Now please observe this. So this behavior is very unique, and if we increase the speed further, say we are going to a little bit higher speed to 2000 approximately, you see this side the 2000 RPM is there. The moment I leave it, this behavior will be very interesting, and you see the rotation is clockwise. Okay, now let me stop it over here and let me explain the reason behind it, why it has happened so. Students, let us see why it has happened so. The behavior is unexpected, and that is called gyroscopic effect. First of all, as you have seen, the rotor was rotating like this. You can put a mark over here with the help of a chalk. This was the direction of the rotation. Right? You can just confirm it. Right? It is all right. Now the direction of the rotation you have seen. If you consider this rotation clockwise, if you see from this front side, the angular direction of angular momentum will be represented by the right hand screw rule. Because it is rotating clockwise, the angular momentum direction will be like this. Say this is the arrowhead. So the rotation is clockwise, but the angular momentum, which is the product of moment of inertia of the disc and angular speed of the disc, if you multiply those two things, this will give you some magnitude, but the direction will be given by this arrow. So this is the arrow. You can say this is the arrow. Because you put the right hand, rotation is like this, so the direction will be in that direction. Right? Now if you give a weight over here, what we are doing? We are trying to give a torque in this direction. Right? If you give a weight over here, that means we are giving a torque in this direction, which can be represented by this. Right? By giving a torque over here, see, if you give a torque over here, what will happen? The torque basically will try to, this torque you are giving in this direction. You see, you are putting weight over here, so the torque will be in this direction. Again, you can use your right hand thumb rule. You hold it like this. Right? Torque is in this direction. So the arrow will be turned like this, because this is the concept of vector. This is a vector, and now you are giving a torque in this direction, so this vector will be rotated like this, and that is the thing we have observed right now, and this effect is called gyroscopic effect. And our objective is to verify the law of gyroscope, which is a very simple law, has been given in that it has been observed the speed of spin. This is a precession. The speed of precession basically depends upon the moment of inertia of this disc, number one, speed of spin of the disc, number two, and the torque we are giving by putting a mass over here, right? So let me again tell you the effect, gyroscopic effect, which is the rotation of the setup about the vertical axis, will depend upon three parameters. Number one, the speed of this disc, angular speed of the disc, number one. Number two, moment of inertia of the disc. Number three, torque provided over here by putting this mass. There is a relation has been given mathematically, and now our objective is to verify that relation. Just to verify the relation, we have to do the activities required. Number one, first of all, we will get the moment of inertia of this disc. And as we know, the moment of inertia of a disc is m r square divided by 2, right? So mass of the disc has to be calculated first, radius of the disc has to be measured, and with these two parameters we can find out the moment of inertia of the disc. It has been found that the weight of the disc comes as 4 kilogram, and if you want to measure the weight of the disc on this setup, it is not possible. Now how can we do it? For that, first of all, we will have to take the dimension of the disc, right? You can measure this with the vernier caliper. It comes as 250 millimeter. Then measure the thickness. It comes as 10 millimeter. And the density of steel, must remember that it is 7.85 grams per cubic centimeter. So this way, if you calculate, we find the weight comes as around 4 kilogram, right? That is one important thing. And once the mass is known, radius is known, the moment of inertia can be calculated. So that part would be a constant for our experiment, right? And one thing to be noted over here is the mass of the rotating part inside the motor is almost negligible, because the radius of rotation is very small. But if you want a very precise calculation, we will also have to consider that part, right? That is one thing. Now, the second parameter is the speed of spin. The moment we start and the speed stabilizes, say at 2000 RPM, that is the speed of a spin in revolution per minute. But for the calculation, we have to convert it into radian per second, right? The formula you know all, 2 pi n by 60, right? So this way, this is calculated. Now, after doing this, two activities. First is measurement of the moment of inertia. Second is starting of the system and stabilizing a particular speed. Then the most important parameter is put the weight over here gradually, and the moment you leave it, as we have seen, it starts rotating in this direction, right? And for 100 degree on the base, we should calculate or note down the time, right? And that can be taken as 50 degree also, but 50 or 100 degree would be sufficient for the calculation. If we know the time period for this rotation, we can find out the speed of precession. Okay, now we have got moment of inertia of the wheel, speed of spin of the wheel, which is directly represented over here right? This gives over here. And lastly, we note down the speed let us assume that I have put a weight of how much? It is approximately 450 grams, right? And as this speed is over here at 2200, now we just leave it and see how much time it takes to cover 50 degree. So now it has come, it takes almost 15 seconds to reach over there, right? One thing we observe that as the speed increases, you see, it becomes more balanced, right? We can see that as the speed goes increasing 3000 RPM, that becomes more smooth, right? Now one more important thing can be performed. We can increase the weight further. Putting the scale at 0 at the base, we can increase the speed now to we can see the speed increase by putting 2 weights, almost 1 kilogram. The speed increases further and it is more balanced. Ultimately we find that the speed also depends upon the applied torque, right? Okay. Students, now after performing the experiment, we have to come back to our objective, which was to verification of the law of gyroscopic couple. Right? The formula has been theoretically derived like this. Right? R means reactive couple, C means couple. This gyroscopic reactive couple is given by this very small formula. I is the moment of inertia, mass moment of inertia of the system. Not the system, only the wheel, spinning wheel. Omega S is the angular speed of the wheel in radian per second. Omega P, the precision of the axis of the spinning wheel. So basically 3 parameters are there. The first parameter is a constant for all the experiments you are going to perform on this setup. This parameter will depend upon the RPM we are selecting with the help of the regulator, which is being displayed in revolution per second, but will be converted ultimately into radian per second using this very simple formula, right? And omega P is the precision, which was our last observation after putting the weight and leaving the setup to freely process. And that can be calculated just by getting the total angle of precision. In our case, maybe 50 degree, maybe 70 degree, whatever it is, and that after converting it into radian, we divide it by the time taken for the precision. So that speed of precision will be available over here, right? So 3 parameters to be calculated. First is moment of inertia. For that, we see the disc has got 250 millimeter diameter, 10 millimeter thickness. So we can calculate if the density of steel has been given as 7.85 gram per cubic centimeter. And moment of inertia will be calculated using this formula, and it comes as this much, 0.0312 kilogram meter square. Okay. After doing this experiment, we can perform for 2-3 observations. 1, 2, 3. In the first observation, we will note down the spin which depends upon us, which we adjust to the regulator. In our case, we have taken 2000 RPM, maybe 2013, 14 immaterial. The next you can take at 3000 and 4000. It may be some plus minus immaterial. Then we will note down the theta of precision. Say in every time we will be putting say 75 degree. So convert it into radian, into pi into 180. 75 pi into 180 degree, right? And time we will have to note down with the help of a stopwatch. So whatever time comes, we'll note it down. T1, T2, T3, right? When we divide this by this, we will be getting this 2, 3 information will be available, and the value this much will be calculated. How can we calculate? I we know this is calculated already and will be constant for all the observations. Omega s will be taken from here. This 2000 into 2 pi 60, 3000 into 2 pi 60, 2 pi by 60. So omega s will be taken from here, omega p from here, and we will calculate these things. These three data will be collected. Now the question is that this value is theoretical, right? Because we are using this formula for reactive couple. Just to verify, as the objective was to verify the law, then what we have to do, we have to do one more activity. Whatever mass we have given, say in the first case, first experiment, you have given 450 gram. So convert it into kilogram, so it comes in kilogram weight. In the second case, you are giving again, say 900 grams. So it comes as 0.9 kilogram. And in the last, you can give 1.5 kilogram. So any value you can put, because these dead weights are with you, right? And now you look at this picture. I'm just taking the front view of the setup. Here is the motor, is shaft, and is the disc, rotating disc. With the help of a scale, just measure this distance, center of the disc to the weight where we are putting the weight, right? This comes as 195 mm. Multiply this 195 mm, converting it into millimeter with this weight. Then the actual, then we'll be getting the real torque, applied torque. This is the applied torque 1, applied torque 2, applied torque 3, and to conclude whether the law is verified or not, we have to compare these two parameters. First is this theoretically calculated gyroscopic couple, and this is the practically applied practically applied couple. These should be equal, 100%. But practically there will be certain deviation, maybe 5%, 10% error will be there due to human error in taking the measurement, as well as friction available between the shafts and bushes, shaft and bearing of the setup. And to do this experiment, we should have some precautions. The speed should be monitored very gradually. We should not touch the setup while working, and the calculations should be very precisely done, because our purpose is to compare the actual applied torque and the theoretically calculated torque.